call it operators. It is very interesting topic and important one as well, as far as the working is considered. And why I'm saying that this is important as well, because this is the building from this topic we will create some building block information, and that would be used in the later stage as well, in the topic related to differentiation, numerical differentiation, and finite difference method, and also in the interpolation curve fitting when we have to define some function based on these operators theory. This is also a very interesting topic, and I must say it is not that difficult as well. You just need to focus on some basic symbols that and their definitions, which you can do it easily. So let's start this topic, but and before, because the new topic, so let's build some background information about it. So now think about the following point. Then after that I will give you the proper definition of it. So let's connect it with the topic that we have just covered so that we have some idea. So student, for example, if this is the function y equal to x square, and I've asked you, so what is the derivative of y with respect to x? So you all know 2x. How? Because you all memorize that dy over dx equal to 2x. So you can compute the derivative. So this is your answer. Let's analyze or consider this situation in some other perspective. So technically what you have done, you have a function which is represented as in this example as an x square. What you did, you put this function under certain operate under a process, and the process is here is differentiation, and you get some output or some value, which is in this case is 2x. So I can say this is the process you have done many times, you know it, but to connect with operators, let's analyze the same thing in some different perspective. So there is an input, that is a function you want to compute derivative. So you input that function into some process represented by a box. Here we all know the process is a process of differentiation, and you will get some output, that is your 2x or whatever be. Now so let label them. This is some sort of input, that is output, and some process. I hope you understand the basic point. Derivative you have done, the rules are still the same, but I am connecting it with the operator. So what you have done, basically when you learn differentiation, you memorize it or you learn the definition of dy over dx. You know that this operator, this symbol, not use the word operator here, let's say call it symbol, d over dx means that you want to compute the change in certain variable which is dependent in our case with respect to the independent variable. It has a predefined definition. It is a symbol, but it has a predefined definition, and in universe whenever this operator appears in front of any function, it has the same meaning, that is you want to compute the change in one variable with respect to the other variable. So what you did, you have an input, that is a function, you input it and you get the output. So if I represent the same thing in a general format, so I can say if I have any function f of x, input it in a process in which I apply the differentiation, I will get some output which is f dash of x. Similarly, derivative is not only the example. For example, there is a function, you process it with the You know this symbol very well, integral, and you get integration, sorry, and you get some answer. So let's call it some answer. So you get some answer there. So why we are getting some answer? Because all these symbols that we are using in mathematics has certain predefined definition in it, and whenever they apply on that function, it performs their duty. So basically, they are called operators in a mathematics. We call them differential operator because it's compute derivatives. It's called integral operator because it defines the integration, and you can define as many as operators you can, but it has to follow certain conditions, although that is related to a mathematical details. But the point is, you when you define operators, you have to use them as well, so it has some familiarity with the calculations as well, or is in your calculation. So this is just an example of the operators from integral or differentiation. So you can define the operators uh, to yourself. It is not necessary that operator always need a single function as input or output as a one function. It can give multiple outputs or multiple functions, but this is just an idea. For example, uh, you know arithmetic operators like addition, subtraction, multiplication, division. So you know that, for example, if there are two numbers 2 and 3, you input them in an operator of addition, you get certain answer based on this definition 5. So operators there: process, output, input, process, output. So what operators do? Operators are nothing, they are just symbols which have a predefined definition in it. So what we can say, operators, obviously we are discussing with respect to mathematics, so it is not a telephone operator. So I hope you understand. Operators means a symbol that have predefined definition stored in it. What predefined definition stored? What does this mean here? So here the operator is differential, dy over dx. What is the definition in it? It says whenever it operates over the function, it computes the change in it. Its definition. You cannot find a derivative which give you the integration. You always have a derivative that gives you the change in that function, because it's definition. Simple summation, addition. Algebraically, when you add something, you always add like that because it's a predefined definition. You cannot use plus symbol for subtraction because it is a defined. So in mathematics, we do this a lot. So this is just a background. Whatever I have discussed here, obviously we are not going to solve such a basic things, but this is just to give you some background of what we are going to discuss in this topic. So yes, we have to deal with some symbols, and symbols have some definitions, and we have to use them in such a way that we can create some purposeful knowledge that we as an engineer or a mathematician face during the calculations. So let's move ahead and define some operators that are very useful for our calculation. So let's move ahead. So first operator that we have to discuss is but before to give the name of that operator, I suggest let's consider some function, that is y equal to f of x, but that function is not, in fact, leave this part at the moment. Let's say y equal to f(x), there is a function. So we know that if there is a value x naught, and if I put x naught in this function, so I will get certain answer. Let's say y naught, which is basically nothing, is equal to value of the function evaluated at x naught. Similarly, if I have value x1, and if I put that value in it, I will get y1, which is the value of the function at x1. Similarly, let's say x2, and there is a y2, and if I put that value in it, I will get x2. So this is the way how to compute a numerical value, but that value is equal to y2, y1, y0. So one can clearly understand. If I continue similarly, let's say there is some value xn, so I will get yn. And how do I got this value? By putting the value of xn in a function. I hope this part is clear to you. So what I got at the end, I got a data. In that data, what I have two arguments. One is x values, x0, x1, x2, x3, and then the other values y0, y1, y2 until yn. These are just a data sets. So what I can do, I can write down them in this tabular form as well, if required, but it's not necessary all the time in horizontally. For example, like this, I can write down them. These are x values, these are y values. So x0, x1, x2 till certain last value called xn. And similarly, I get corresponding y0, y1, y2 till yn. So these are the operator. These are just a simple data set. We have not defined anything with operations at the moment, so we are not doing with it. But let's move to connect this part, this data, with the operator. Keep in mind, student, I will use these references many times during the lecture, maybe on the other slides as well, so you have to come back and look on these slides. So x0, what is a variable, independent, and the corresponding value is y0, which is obtained by using the following. X1 is an independent variable, corresponding value of dependent is y1, x2, y2, xn, y. So we have this pair. We usually call them ordered pairs and other thing as well, but let's say these are just a data set, discrete data. Keep in mind, what does it mean? We have x0 and then we have x1, although there exists many points in between, but we are not considering them. So there is x0 and then x1. So I can say there is some difference between x0 and x1. Let's call that difference is h. Keep in mind, this is a difference between only x0 or x1. For example, x0 is 0 and x1 is 2. So I can say the difference between this is 2. Let's say the other point x2 has a difference 3. So 2 and 3 has a value 3. X1 has a value 2 and x2 has a value 3. So I can say the difference between these two is 1. So this gap, this variable h, represents the difference between the two values. So here we assume that the values at the moment have an equal distance, that is, difference between all the values are same, although whatever we will discuss can be defined for the values which are not equal to the same height, same difference. However, keep in mind this h has nothing to do with y quantities. Y quantities are purely depending on those values through this function f of x. Now student, why I cut this line is sometimes we have this relation defined closed form, like you have given a function exactly, or sometimes you just have a data because you do some experimental work, you only get readings. For example, you decided to note a current after every 1 minute, so you only have a readings based on the time. So your x variable is a time and the y variable is current, so you only get readings like at t0 current is this, at t1 the current is this amount, at t2 current is this amount, and at certain t n time the current is this amount. So you don't have a function there maybe you are reading some experimental reading, but you only have a data. So keep in mind at backend that there exists some functional relation that connect those variables, but we don't know that. So this is also possible, that's why I cut it. But sometimes this function is given to us as well, so we can assume some properties in the data based on the given function. So keep in mind that sometimes we only have a data in this tabular form. In fact, most of the time we will deal with this because we are discussing perspective respect to engineering side. So we have data and then we try to do some calculation based on the operators, which I will explain later. But keep in mind that a function, those data must be related with certain function, which is not necessary we know in advance. Okay, so let's define the operators. Again, I will use this data many times. So operator the first operator is called shift operator. Shift operator. Obviously it's just not a operator like a shift operator in a factory or somewhere. It is mathematical operator, so it has a symbol. We represent shift operator by a symbol. Let's say in books we can find different, but let's we call E, capital E. So what does shift operator do? Obviously it is operator, it has some definition inside it. So whenever the functions comes in front of it, it applies that definition. It is not like a definition of derivative or integration, it has some definition. So what is the definition it has? So let me write down the definition in mathematically, and then you will understand its concept. So student, for example, if I select any point from there, these points, any one of them, for example if I select x0, so I can say x0, x1, x2. So what I do, let's say I select any point x, so this point could be any of this point. Then is it true that I can say if I select x0, the other point x1 is basically situated at a distance of h units from x0? Because I already told you that all the points are at a distance of each other with the h. So what I can say in other words is x1 is situated at a distance of h from the x0. So if I add x0 plus h, I will get there. Similarly, if I add x1 plus h, I will get to x2. If I add x2 plus h, I will get to x3 and so on. So I can clearly say if there is any point x and other point is x plus h, so basically they are two consecutive points. So for example, if I label this point x as x0, just for your understanding, so this point is x0 plus h, which is basically equal to x1. Similarly, if I select randomly any point, let's say x2, so the consecutive point that is on the right hand side, the point is x2 plus h is 3, x3 I mean. And similarly we can define other consecutive points. So what does shift operator has to do with this value? So student, you have no, I hope you have noted that whatever the example I have given here, I have dealt with the independent variable, that is x variable. Here you cannot find anything related to dependent variable. So what shift operator do? Shift operator is operator, so it applies on the function. What is do? If you apply that function, like you want to shift the function, so when you apply this on any function, I hope you can resemble it. Let's say if I have a dy over dx here, you know that I have to compute the derivative of this function, but that was a differential operator. Here it is a shift operator, so I want to apply the shift operator on a function f of x. So what definition this operator has inside? It says whenever you apply a shift operator over the function, it will shift that value to its consecutive term, that is x plus h. It is not x, in fact the value of the function. So if I apply f of x on sorry, other way around, if I apply operator on f of x, so it will assign assign this function a value which is the value of the function ahead of that value. So x is the value, so the value which is ahead is x plus h. So this is the basic definition of the operator. It just assigns a value. There is no complex process to compute, it will assign a value. So for example, this is written in the form of function. I can write down in a compact notation as well. For example, I want to apply this operator, shift operator on x naught. So what I can do, I can write down it like e applied at x naught. So this is equal to, we know that what is the value which is on the shifted on the right hand side of x naught. We all know the value which is on the right hand side is x naught plus h. So if you add something x naught plus h, you will reach to the x1. So what you have to do, you have to read the function at basically f of x1. So this is the operator. E f of x naught is nothing, is equal to, whenever you apply a function, it will assign the value which is lying ahead of this value. So let's think about here. So if I want to compute E f of x naught here, it will assign the value which is ahead of it. If I apply E f of x1 here, it will assign the value which is ahead of it. So it will continue like that. So I can write down, rather than using this f of x naught or everything, I can do some other thing, because I know that f of x naught is equal to y naught. So what I can say, I can write it down like that, a shift operator, rather than using this whole term, I can simply type y naught. A shift operator applied to a y naught, which is the value of the function at x naught through the function f of x, is equal to y1, because f of x1 is equal to the y1. So it is for numerical values. So if I apply the forward shift on this quantity, I will get this quantity. In fact, I have used that word. Listen, you can see if I am applying operator in this value, so I am assigning it the value which is lying in the forward direction. So I call it forward shift as well. So but this is the basic definition of the shift operator. So I'm shifting it forward, which means that there is some chance that I can shift it backward as well. So there is no calculation required. You do not need to do any calculation, you just need to assign the values. So if the data is situated at a distance of h, because here you can see the h is the basic definition. So this is the definition of the shift operator, but keep in mind, shift operator works in both directions. It can shift value forward and it can shift value backward as well. So it depends how do you deal with the example. So how do we represent it then? It is a very simple idea. So general rule is, if you apply a shift operator in this form, that is ef of x, so it means that you want to shift forward, you want to shift forward. This is forward shift. But if you apply the shift operator in this form, e raised to the power minus 1, although do not consider power, it is the operator e power minus 1. So it means that you want to shift it backward. Minus signs means backward shift. Now what does this means? What does this means if we have a backward shift? So let's do this in our next slide. So So for example, you have a data x0, x1, x2 and so on, and the corresponding values again y0, y1, y2 and so on. Let's say last value xn and yn. So if I apply a forward shift on any value, I can move forward. But what if I apply the quantity like this, e -1 on y2? So basically I'm applying the shift operator on y2, but I want to shift this quantity corresponding to x2 towards back of that value. So which value lies on the back side of y2 is corresponding to x2, and it corresponds to backward value is x1, and x1 has a value y1. So what I can say, the shift of y2 will result a y1, 1 unit shift of y2. So this is the simple criteria. So it means that shift operator that we are dealing now, it is backward, but it's a very simple idea. It will just navigate us between the data. So we can move forward with reference to certain value, or we can move backward with reference to the certain value. I hope you understand the following points here related to our calculation. Similarly, students, we can define forward backward, but here keep in mind that all the data set is situated at a distance of h units with each other. Similarly, so this is the operator definition. Forward backward, now the point but is, here keep in mind that all the data set is situated at a distance of h units with each other. So this is the operator definition. Now the point is, this is your shift operator. We can discuss it further as well. Let's make it little bit more complicated operator. What do you understand if I write down a shift operator in this form, plus half on any value of f of x? So one thing we have learned, that if it is a plus, which means that we have to move forward shift. But what does this half means here? That's confusing. So let's recall this operator first. I have introduced it to you, e of f of x. I call it shift operator or forward shift. But keep in mind that it is defined like that, but I can also write it like +1. So e +1 means we want to move it forward. How many units? 1 unit, 1 complete unit. So this means if I apply shift operator on x0, due to the plus sign, I will move forward. But how many units? H units, that is 1 unit. If it is a backward operator, if I apply on the second value, negative means I have to move backward. But how many units? I have to move 1 unit. So this means negative is for backward, and that amount is how many h you want to move. So one can clearly see, if I am here, I can move 1 unit of h backward and 1 unit of h. I cannot move further because in this case I will go outside the data. So this means that there are two things important in the shift operator. One is sign, that is you want to move backward or forward, and the amount of magnitude. So if I say half of it, this means that I want to move forward from certain value x, but not completely. I want to move half of the distance only. So what does this mean? So for example, you want to compute e half of f of x naught, for example, and the data is defined like that. The first value is x naught, and the other value obviously is x1 and so on, and corresponding values are y0, y1 and so on. But keep in mind that the distance between these two values is h. So if I say you want to compute this quantity, so you have to look for this value. So you want to apply a shift operator forward shift operator because of plus sign on this value. So this means that you have to read its dependent value because there is a function. So you want to apply here, but this quantity says you have to go half of the length in a forward direction. So I have to move from here, not to here, because if I move exactly one length here, then it is more than half. I have to move somewhere in between. So you remember in the last slide I said there exists a certain function, but we are only selecting some data set, so we do not need. So if I have to move to certain value here and I want to read that value which is not available in this graph, so how I can write it down? I can write it down, I want to shift from x naught of the value half a distance in the positive forward direction, not positive, in a forward direction. So what does this mean? I want to move from there to somewhere there in x value, although we don't move in x value, which is basically equal to x naught plus half of h. This is the value, but here I don't know that value because I have only noted the data at x naught, x1, y naught, y1. Although I have not noted the data on y, so I cannot find this reading, so it's a question mark there. However, for independent variable it is up to us. For example, if I note the data at x naught is 0 and x1 is 1, so I know that the half of this is 0.5, so I can move between these two data at a 0.5 reading. Let me write down, I think it's not clear here. So for example, the x naught is 0 and x1 is 1, so I know that which one is the half of the distance. Is obviously the half of the distance is 0.5. I can do that quantity, but I cannot do it here because we don't know the value of the function at this coordinate, that is 0.5. So let's put it question mark here in this case. So this means that we can navigate, but we can navigate any value. However, if we navigate or switch to a full length of h, that is 1 or 2 or 3, then we will get some answer from the y values. But if we move somewhere else, we will never get the value. So let's think about it. How? Let's have a quick example. What do you think where I want to shift from this quantity plus let's say I want to say 1.5. Yeah, you can use decimals as well, of x naught. What do you think where I want to shift? It is not half, it is 1.5. Take a pause and think about it. Where I want to shift? I want to apply the operator here, but I want to move 1.5 length of h. So 1.5 length of h is quite clear that with 1 I mean to cover 1 complete length and half length further, because if it is 2 here, then I want to move from x0 to x2, but it's not 2, it is 1 length complete and half of the length apart from it. So what will happen in this case? If this is x0, this is x1 and this is x2, and we know that all are h unit apart. So what will happen? I will move these y values from y0 to y1, that is moving 1h, and I can move to y2, that is moving 2h, but I do not want to move complete 2h, I want to move 1.5 of h, which means that 1 complete length and the half of the other length. So where I will move from here, 1 complete length and half of the other length, 1.5 of h. So the quick technique is always multiply this quantity by h and take the reference from there. So basically I want to move from there. So this point is basically x1 plus h by 2, which we can compute, but we don't know the reading here because we only noted the reading at y1 which correspond to x1 and y2 which is correspond to x2. There is no reading, so it is a missing here. So but how we can represent that missing value? We can write it down e plus half of this quantity. So this is the way. Now student, you can easily understand that plus means forward. I move in all this example, I move forward. I can do similar everything for the backward as well. I just need to put a negative sign here. So that's the only part. Important point is, student, if this is the data set, so this is the first value and this is the last value arranged in an increasing order, x values, y could be any order. So if I apply a shift operator on the first value, I will assign it forward value. Whenever I say forward or shift, we usually consider h equal to 1 times of h, any complete h we want to consider. But sometimes we need to have any fractions as well, but in general we usually have a multiple of h. So we can move 1 unit. If I say x1, I want to apply a shift operator, I can move forward 1 unit. The problem is whenever I move to the last value, I cannot apply a forward shift, because if I move forward to that data, I am going outside the data set. So whatever I have to do, I have to do within the data set, the operations at the moment. So keep in mind that on the last value, you cannot apply a forward shift. Okay. So last value, you cannot apply a forward shift because value does not lie outside the data. Similarly, this is the first value. So if you apply a backward shift on the first value, you cannot do that because you cannot move further backward from this data. For example, if you apply backward on a y1, you can move to y0, no problem. But if you apply a backward on y0, you will move to back of this data, which does not exist here. There is no data here, so you cannot go. So what are the points? Point is no forward, shift for no forward shift for what? Last data, and no backward shift for first data, because data does not lie there. So this is the point that you have to keep in mind. So I hope you understand the concept of this shift operator, that it will just try to navigate between the data sets to move it. How we will use it and what is the purpose of use it is a different thing, but you have to keep in mind how do we use these operators to move between the data sets in this example. So let's move ahead for one more data. It's called